Well, that was fun. Just record an hour and I can extend it or deal with a crash or something. Yeah, at first you don't succeed. And that is the secret to AI, life, many things. Unless you're doing something different, then okay, so today we are in week 10. Okay, and so these notebooks have already been marked on because again, the second time reporting it. But third time actually. But it will be better. Promise. So the main thing I want you to walk away this week with is retrieval augmented generation. I want you to understand what it is. There's a few other things we talk about. I don't think we're covering vector database. We covered that in the past. We're going to go over prompt uh, engineering. We're going to go over COT. And I just have a paper on COT that I submitted. Well, I submitted one on, I think, Sunday, like 3 days ago, and then one yesterday. So it's fresh in my mind. I can talk to you about a lot and why it's important and the pros and cons of it. So, but the main thing I want you to walk away is retrieval augmented generation because it seems that there's two sides of the fence. I don't know what word to use. People love it or people hate it, and I'm right in the in between. I love retrieval augmented generation when used right, when deployed right, when designed right. Problem is, a lot of people throw rag at problems that it shouldn't solve. That's one of the issues. So, and now there's also going to be a change too because I am going to use this. So these are Gemini and me working together, making slides. And there's spelling mistakes. I understand they're not mine. They're Google's. I can't change it because it's a JPEG wrapped in a PowerPoint. Right? I mean, I can't edit them. They're literally a picture. There's no editing. But I think it's important to go over these because I've updated the slides. Now, why have I updated slides? I've updated slides because since this class, so 2026. So, well, what has happened, Richard? You know, nothing changed in AI. Start with OpenClaw. OpenClaw is the idea that computers or LLMs can do things. Super important. Before, and I mean, before we had things like Mantis, which again in 2026 got bought out by Facebook, computers and LLMs could do things, but not like OpenClaw. So that's a huge, I guess, change in industry. Um, let's see, GPT 5.4, I think Opus or 6. Now, also something that's interesting too is, you know, early in the semester we talked about open source OS, not to be confused with Microsoft OS, and closed source. Okay. Now you have two fundamental types of models. You have GPT from OpenAI. You have Anthropic's Claude. Right. No, I'm gonna write better. I just really want to get through this. And then you have open source, and your open sources are Quinn, for example, DeepSeek, Meta. Some of Meta's models are GLM, Hemi, just to name a few. Now, when they're open source, you can download them and you can add to them. You can make them better. You can play with its guts. I have a dog that wants to come up. Come on, Lucky. And I don't know how to say that. You want to say hi to everybody now that I'm back teaching? Hi, class. Um, um, and not that one is better than the other, but there's fundamentally different uses or designs or things like that. Well, it's hard because OpenAI and Anthropic spend millions and billions of dollars training their model, just as Quinn, DeepSeek, Chemi, GLM does, but GLM give it out for free. However, there's a few caveats. It's not like you can run this on your home computer. Something like DeepSeek, the full huge version of DeepSeek, it's huge. You can't really run it at home. You can quantize it. There's other hacks you can do. We'll talk about that later. But one of the things that you're starting to see now in the world, at least with open source, they give you like a preview, or I don't want to call it a preview model, but it's a free version of the full weight of the model, and then they'll keep the full weight private model. So, and ChatGPT tried to do this with OSS and other things, and it's interesting. So that's a huge change. Okay, that affects a lot of what we do. Oh, what else? So this year, I have a whole nother slide on this I did for, like I said, AI can now refill RXs in Utah. Huge change. What else? Mistral release models. I mean, there's just so much going on. News stories. Just ChatGPT, might as well do that. And because of that, it's hard to find slides or to keep slides up to date, because I don't want you to be at an executive level where you don't really know the guts, and I don't want you to be at a CS level where all you care about is picking one particular algorithm over another algorithm. I want you to be in that warm middle where you can use AI to solve problems. You can use AI to make the world better. You can use AI to make a change for the better. And that, sorry, that, well, AI and ads, that's new this year. um, and that's kind of where I want you to be. And it's hard because that's what changes. The executive stuff really doesn't change. And ooh, got a bad cough. Some of the CS stuff does change, but I don't think it changes as fast as the utilization and optimization and business deployment of this stuff. Okay, so there's that. So let's dig into the class. Let's not dilly-daddle around. Great word. So just to give you a heads up, I will have the PowerPoint and also the other PowerPoint that we'll talk about. This PowerPoint. They're fundamentally the same. I just basically kind of distilled this and made the other PowerPoints with new updated information. So I might switch back and forth. You might be confused, but we're learning in educational life. So let's dig in. Okay, so week 10. We heard about that. Okay, so I've been also grading. You guys that Analyze Me have been phenomenal. I'm really impressed with Analyze Me. Just keep up the good work. For Analyze Me 2, you can't use the exact same data set, but you can use the same domain. So if you look at forestry, there's 20 data sets of forestry. You look at used cars, you can use Craigslist versus eBay. And there's a lot of different data sources. So as long as you don't use the exact same data source, you can use the same domain specificity or the same domain knowledge that you have, or you can completely change it around. Okay. That's amazing. I didn't create an ethics video yet. I think I'm gonna do that at the end of the semester. That's technically when it's due. A lot of what I do is in safety, guardrails, and AI, because it's just so, I guess, unexplored. It is so. We're allowing LLMs to refill prescriptions. Wouldn't you like to know they're safe? At least as safe as a human. We're maybe soon going to allow LLMs to deploy weapons. Wouldn't you like to know it's doing the right thing? So ethics is a huge issue, and it's often overlooked. No, that's just because, hey, look, it's fun, it's this, blah, blah, blah. Prompt engineering. So I guess we can start with prompt engineering. I have a couple of infographics I had Gemini and myself make. Let's switch over to those real quick. And prompt engineering it's important because once you move from just asking ChatGPT questions or any LLM, you provide a much bigger context programmatically. And when you provide it bigger context programmatically, the prompt becomes more important. So, and there was a good thread on Reddit if somebody wants to post it. Probably, I don't know, beginning of March, about how I think it was OpenAI engineers use how they prompt better. And then one of the reasons they prompt better is because they give examples first. So anyway, so let's dig in here a little bit. So okay, so with prompting, give direction. What are you looking for? You're looking for a scientific answer. You're looking for a general answer. You're looking for a business answer. There's something called a role. You can provide a role. Hey, as a senior machine learning engineer, please review my code. As a high school student with no programming experience, please review my code. Better believe you're going to get two different outputs on that. Specify format. Do you want it just as text? Do you want it as Markdown? Do you want it as JSON? Want to, what format do you want as an output? Because now we're talking more about not just necessarily using chat GPT to query, but more an API and sending, hundreds to, millions of prompts. Okay. So how do we want the results? Can we provide an example? When you say you want something, a date format, how do you want that? Look at it. I mean, don't just run a million. Hopefully, you guys know, but just run a million queries. Run it, analyze it, run it, analyze it, run it, analyze it. For some reason lately, I've had a lot of problem with some of the LLMs I've been using, where it wants to run, 30 million rows. I'm like, no, let's just get it from start to finish working, with a limit, and then we can make it bigger. And, again, that's something new. And I remember that in 2026 is divide labor. There's a couple different ways that this can be interpreted in prompt engineering. The way I'm going to interpret it and the way I'm going to explain it is basically as subagents. I'm a big believer in subagents, and they're relatively new. So a subagent is when you have two or three prompts running at the same time that are independent of each other, that kind of contribute to each other. Okay. So if I ask Chat GPT or Claude to do something and it can use subagents, each one of those subagents has its own context window, has its own ability to think, has its own ability to do things. And one of the huge advantages is, since I'm not loading everything in memory, and in theory, that subagent is a domain specialist of what it's doing, it should perform it better, quicker, faster, and cheaper. Compared to if you have one agent that has all of its memory, all of its words, all of its context loaded in its memory, has this huge cognitive load, and you ask it to do something, it can do it, but it might get confused. So there's that. Let's see. Guide logic, prompt hacking versus reasoning models. Okay, so now there's two basic types of reasoning models. It's three, and we'll just break it down to non-reasoning and reasoning models. Non-reasoning are ChatGPT 3.5, I think 4. Some of the Chinese models. If you make it and you don't use reasoning tokens, then off that. Those types of models are the non-reasoning. You just ask them a question, they give you an answer. Well, then you have reasoning models or chain of thought models, COT models, and they kind of iterate back to themselves. It's much like how we as humans do. Now, how do I solve this problem? Well, I remember I have to set up the division and numerator, denominator, fraction. Okay, that's how I do it. And you think to yourself, you process through set of steps in order to get to a goal. Reasoning models talk back and forth, talk through themselves, talk to themselves. They reason through their logic. I just submitted 2 papers on chain of thought prompting, and I'm going to do another one at the end of the week about faithfulness and other issues that chain of thought models might have a problem with. Basically, at the end of the day, if I ask a non-reasoning model question, I ask it, boom, it gives me one answer. If I ask a reasoning model or chain of thought model, I ask it a question, then it asks how it can make that output better, and then it does, and it asks how to make the output better. It does, and it kind of reasons through it until it gets to an answer it feels is better. Okay. Um, so I believe that, yeah, the Army book has a lot better or some really good examples of how to do prompt engineering better. And there's a lot of examples on it. I don't want to do presentation mode because then full screen. And this is what I was talking about on this slide right here. There's a difference between just going to Chat GPT or Claude or somewhere and just asking a question versus, using API to send hundreds of queries. Okay. Um, and like I said, when we get to RAG, we'll talk about how we can kind of eliminate hallucinations, but still, I think hallucinations are slowly declining and it's less of a problem than it was last year. So with chain of thought, you basically ask it, hey, show me the reasoning, show me the steps. How did you get there? Yeah, think step by step. And now again, on all the reasoning models, it does it automatically. And you can see that right here. Let's see if I can find. Oh, look at that. I'm behind that. Let me see if I can fix it. You guys, there we go. Sorry about that. What what are qubits and why are they important in quantum mechanics, computing, and how might an analogy to a veterinarian be applied? So, and thinking here. Some of the other models will have like reasoning high, low, or medium. Or here, you know what? I got another example. So if you go back over here for the chain of thought, um, oh, I just saw it. Model effort. So the effort right here is basically that. How many times it reasons through a problem. Kind of. Uh, High effort, more reasoning, more energy, more cost. Less reasoning, less this. So this is a chain of thought prompt I'm working on. I was going to demo, but I might as well, since we're here right now, we might as well show you. Okay, so the question was the crown of the very curious tooth suddenly fractured, blah, blah, blah. So it's some type of multiple choice questioning. Okay, so here's reasoning tokens, hidden chain of thought, 200, blah, blah. The main bracket off the trachea, da, da, da. Final answer. The correct answer is A. This is what the machine thought internally. Now, you used to be able to see these on a lot of the programs, but you can't necessarily. I'm sure there's probably a way you can view them. You used to be able to click thinking and see it. They've hidden a lot of that, but so there's thinking. Great example. Can you find me another example? So that is chain of thought reasoning. So instead of just putting out an answer, it tries to iterate its answer. I'm putting it bigger for you guys. An atomic nucleus, electrical forces tend to, reasoning tokens, hidden. Okay, so here's the first reason token. There's this. You can kind of see how it works through. So the question's asking blah blah. Find an answer visible to user. So you can see how it kind of, instead of just answering it straight away, they ask, hey, the question's asking about electrical forces in the atomic nucleus and what they tend to do. Let me think. I remember that a nucleus is made up of protons. So again, it's kind of giving it context, right? Kind of. And so it's working its way through its logic. So that's kind of what chain of thought reasoning does. Sure. I covered different types of reasoning, deductive reasoning, inductive or inductive logic, things like this. You can look at those real quick, but I want to get to RAG. I think that's really where the money is for this course. The money is, at least for this lecture. Next week it's Laura's and agentic programming. So plan, execute, synthesis. Now with RAGs, there's two types of camps, I guess, maybe on the internet, and maybe it's a bit extreme. I don't know. There's some people that love retrieval augmented generation, some people that hate it, and I'm right in the middle. If it's used right, used appropriately, and it's used well, it's phenomenal. It helps. One of the big things that I've done or I've engineered is visual RAGs. So when you ask a question to an LLM, it gives you an appropriate visual answer. Hey, yo, ChatGPT, this thing bit me and I have a rash. I don't, but I have a rash right here. What's it look like? Or, hey, my poodle will not leave me alone. Needs X, Y, and Z. Oh, I'm looking at X-ray of a broken poodle bone. Okay, what does other common poodle X-rays look like? Well, in our current LLM design, most of the time, if you ask ChatGPT, you ask Claude, it will try to describe an X-ray to you. Horrible, useless. What if it could find images, and I've designed a couple of these, what if we could find images that are related to your query, augment those, and provide you a better answer visually? Hey, this is what a complete fractal, this is what a simple fractal, blah, 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 and show you those. Those are reasons that retrieval augmented generation are invaluable. They're valuable. They're just important. Okay? I'm going to bounce back and forth. So that's where a RAG is good and should be used. Visual RAGs. Where they shouldn't be used is when your domain knowledge or your world knowledge is just not that special. Okay. Um, okay, so sometimes I see them in law, and sometimes I see them in like accounting. Sometimes I think of all the places. Now, idea in law is that you can feed it case law and cases. In theory, it will provide better answers. The problem is ChatGPT and Anthropic and even fully trained LLMs do better, and there's really no reason for a RAG because, in theory, um, what you're dealing with is all public information. The RAG's not the right solution. Now, good solutions, maybe out loud, is maybe if you have a business and you have private, and they don't necessarily mean to be private in terms of corporate secrets, but let's say return policies, return policies, or maybe you work at Ford or Chevy or wherever, and you have a repair manual, and the way you repair is different. If and Chevy. Okay. These might be better uses of RAGs than public information because you're trying to train the LLM on your particular information. So let's get into literally what is. Just let's keep it super simple here. How can we make this as simple as possible? If you have a question, you ask an LLM. LLM kind of looks at weights and does all its math and then gives you an answer. Something like that. What is habeas corpus? All the information, blah blah blah. LLM should be able to answer that. We do the same thing. Question. LLM. Answer. What is my company's return policy? How's an LLM supposed to know that? It doesn't. I know we have 2 or 3 students here that work for MGM. I'm sure they have like I don't even know what MGM's checkout time is. If it's 1 p.m., 4 p.m., 11 a.m., I have no idea. If I go to ChatGPT and say, "Hey, what is my checkout time?" It might not know. What is MGM's, I don't know, maternity leave? What is MGM's policy on bringing your own devices to work? It doesn't know. It can tell you what a return to work policy is, bring your own device, all these things. You can probably take a guess at that, but it doesn't really know. So, what if, let's think about this here. What if we take our documents, double circle. Now we know how to embed them and do all that encoding. And then when we ask the question, we see what documents we have related to that. And we find them and we feed them to the LLM. Then the LLM has our question and the RAG data. So when it processes, it can give an answer that's more accurate. But truly, amazing. We have a system now that can kind of query our internal document source, our knowledge base, what makes us special as a business, grab relevant information, vector similarity search. We talked about this. You can grab, maybe 10 chunks, 15 chunks, pass those to an LLM. LLM will give us a more accurate answer. Richard, why don't I just grab all my documents, send it all to an LLM? You lose context. Too much information for a machine to understand. If I wanted to be a really bad professor, I'd be like, hey, I'm going to test you on anything you've ever learned in your whole life, including any high school courses, any physics courses, any math course you take. I'm going to take, and it's closed book, you can't do, you don't have internet access. I'm going to figure out, hey, you're all graduate students. And you have to have some level of math. I'm gonna look in my math, I don't know, 120 or 181 or 180 calculus book, pick out 3 questions and have you guys do derivatives. I'm gonna pick out stuff from my most abstract English section and have you ask you questions on most abstract English, I don't know, grammar and structure. I'm gonna ask you to name all the different constitutions or the Magna Carta or something. It's just you'll be overwhelmed. That is why we basically take our documents, we encode them, we often re-rank them, we figure out what's relevant. We find 2 or 3 documents or 2 or 3 chunks of data. We send it to an LLM, and LLM can help us answer it. Now the problem is, or where a lot of deficiencies fall, is that a lot of companies try to sell rags. Hey, look, well, blah blah blah, and companies upload documents that don't have any value, or documents are very similar to one another, and they don't really move the needle on anything. They don't impact the thought process. I have training. I don't have it up on my wall. That's what I was looking for. I take training all the time on all different types of things. If I was to upload those to some type of retrieval-augmented generation system and start asking, I don't know, the LLM questions about policies, procedures, it probably wouldn't be very useful because training that I do had nothing to do with those. Even though both of them are provided by my company, probably useless. Um, why don't we fine tune a model? Because it's expensive. Sometimes an LLM will be fine tuned for legal reasons because there's enough lawyers in the world that they can do that. Sometimes it'll be trained, maybe an accountant. You know, there are specialized LLMs. In the medical world, there's like BioBert, trained on biology, or medical BERT on medicine. Um, yeah, go, keep going. So, 10,000 foot overview again. You have a document. You can't send the whole document there. Break up into smaller chunks. You have overlapping chunks. You have an overlap. Then you basically kind of organize all the chunks so the similar ones are together. Maybe you have something about bereavement policies, and boom, you're there. Or, or to look at UNLV, maybe you have, you know, all of the policies related to College of Business, you know, organized. And you have all the policies related to the biology college, School of Life Sciences. Maybe then you also have all the engineering documents organized together. Okay, so you chunk it, and you kind of re-rank, you organize it. And that way, when you ask a question, you can find your answer and other answers around it very quickly. Generate an embedding, a number, and then that's basically kind of what you send. User query, what was our Q3 revenue? Again, something that might not be public information, or LLMs often sometimes lag. It vectorizes your question, which is converts it to a number and then a direction. It searches a vector database. Oh, hey, here's the top 3 chunks. Here's the top 10 chunks. They're most likely to answer the question, or at least help us with the question. We're going to take that and we're going to move it over to to the LLM. We're going to send it to the LLM, combine context, and then send it to the LLM. So, factors affecting RAG quality. Um, yeah, most RAG failures are not retrieval failures, or retrieval failures not content generation. So it cannot find the appropriate document. It can't find things around the appropriate document. Your chunking size is too small. Well, you can't throw a huge document to an LLM, so you decide to, you know, chunk every word. What's the use of that? There's no contextual meaning. We use a bad encoder. I just did tests last week. Test 3 different encoders on some data sets I have. It's important to pick the best encoder, and the only way to do that is by testing. Searching for sometimes slow, chunk size, you know, latency. And a lot of these things are slowly kind of getting worked out. The major ones are probably Pinecone for your vector database system. Um, Databricks has one built into it. Chroma I've used, PG Vector. There's a few others. These are the major ones I can think of. Building a RAG system, and you know, I'm gonna switch over to a couple of the infographics that I uploaded to Canvas. Let's just go over this really quick. Yeah. Not keeping my eraser on. No worries. Okay, so again, we basically talked about this. Take unstructured data, SQL data, documents, PDFs, parse them into text. You have to have some type of text. And I know this one's kind of weird. Then you go down here. Then you figure out, hey, do you want words, which are bad? You want paragraphs? You want sentences? You figure out how big of chunk you want. How big of data do you want to be able to retrieve and store? Bigger chunks have certain advantages in terms of having maybe more context, but also tend to be bad because sometimes, not all LMs have these large context windows. Then you group by ideas or by meaning or by semantic similarity, by something. Why would you do that? Well, you do that because if you're asking about the College of Business, you want all your College of Business documents together. And you apply a 10 to 20% chunk overlap. And this basically ensures that, it says that context is not lost on retrieval, but it's more than that. It's, to get the full picture, I guess maybe context is not lost. Basically, maybe you have a chunk of text here, and you put a little bit, over here and a little bit over here. That way you can bind um, other text to it. Then, okay, and there's other programs here, and I know Google Notebook, Notebook LM, whatever it is not a true foundational RAG. That's a great example of how RAGs work that are easy to understand. Pretty much the same thing. Shall we go back to the PowerPoint? Okay. Okay. Let's dig in. Unstructured maps. Yeah. So SQL RAG pipeline, natural language, text to SQL, or PDF rip or something. You have the SQL query, which and it's not always SQL. It's often vector search, or it depends. Every database you have LLM context. So and it's weird because yeah, I mean I guess fixed chunking size works like this. Semantic chunking or recursive character text splitting um, respects document structure but can result in widely uneven chunks. I mean, some of the chunks are really long, some are really short. Fixed chunk size, that's probably the most common. Um, Here it is, SF Pro. I mean, that's a font. It's an Apple font. I just don't know why I said that. I guess it's using just lower Epson. With fixed chunking size, you say, hey, every 500 characters slice, 500 characters slice. Semantic chunking, you might do it by not necessarily end of sentence, but you do it based on idea or theme. Okay. And LangChain was a really, it still is a really popular way of doing it. Lambda index is another way. I've used LangChain a lot. Like I said, there's a couple different ways to do this. Let's keep going. Okay, so this is a little bit more complex than I probably want to dive into. But if you really think about it, retrieval-augmented generation is not any one step. It's not that final answer. Hard part is getting the whole pipeline working and getting the whole pipeline to work well. Okay, good data, good models, good everything. Okay, the DSP, why I guess matters because it turns that pipeline into quantifiable things you can measure, things you can define, things you can optimize. Okay, um, yeah, it's a pipeline. Um, So the intermediate, the inner guts, the workings, inner workings of rags are what makes a good rag versus a bad rag. What makes a good question, a good answer versus a bad process. Wrong query, the wrong passages, too much content, not enough context, weak filtering, things like this are what make rag strong. And so guess what the DSPy system is. You find what you want before you kind of start designing everything. Optimize and find the best prompts during the design phase, kind of even before some. When your data or LM changes, the system recompiles and updates the prompts automatically. This is where modern AI production is heading. So hopefully that move on to like Hugging Face. Hugging Face has um, pipelines and workflows to do a lot of this. Okay, the transformer library, which I know some of you already use, phenomenal. Um, they have an actual pipeline so you can do rapid development. They have hundreds of models. That's why I do try to push Hugging Face on you. It is super important. That's a useless slide. After here, these are on new slides to me. I've never seen it before. Okay, so hybrid retrieval, yeah, combined sparsely coded, blah blah. Query. Okay. Okay, so hybrid retrieval. I guess we'll just go over each one, the general idea. Hybrid retrieval systems are where things are found in semantic similarities. Um, if you look at dense search, so a lot of neurons firing together, that's good for a semantic similarity. But what if you have something that's rare, rare disease, rare acronyms, rare IDs, and so you design a RAG because again, it's not really common public knowledge. Well, hybrid retrieval is where you do something like that. It uses kind of like semantic searching, keyword coverage, and it's much better at dealing with codes like medical codes, maybe um, jargon, rare genes, rare diseases, things like that. Okay, re-ranking. So after the initial, after the retrieval, re-rankers, and there's a couple of them out there, improve prediction. Basically, they look at like I think the top P, top K, top K. Top K is often noisy, and so it basically kind of reduces that distraction and gives an LM a clearer picture to get the right answer, to get the right document, to get the right chunk of information. Okay? Query transformations. So something I was working on a couple of days ago, a while ago, asked if it can do query optimization, and that is what query transformation is. Okay, it tries to find ways to take what you say, and remember when we did prompt optimization, tries to optimize your prompt. Okay, so you can take a very kind of maybe nebulous or not clear query, or maybe not the word best query, and it can make it better. Okay. An IMRAG basically is when one retrieval is not good enough. And thought reasoning for RAG, I guess is the way I talk about it. So what else we have? Okay, I'm not going to cover this. Search, so I need more information. AI agent core, find query, which we talked about, search agent. So they're kind of talking about deep search. So Google, I think ChatGPT, Claude, even Hugging Face, all have methods of doing deep reports, deep searches, and this is kind of the foundational method of how it works. Um, and I don't know if I'd really consider. I guess these are kind of retrieval augmented generation, but these are like I guess beyond that, and I guess that makes sense because that's literally the section we're working on. you get these reports where it goes out and Googles, it comes down, analyzes what it Googles or what it pulls, and then summarizes that and goes out again, and then comes back and goes out again. You get these deep research reports that are pretty nice. They can sometimes take a while. I mean, they used to take 45 minutes to 2 hours. Now they take 10 or 15 minutes. Um, they're very valuable when you're doing foundational or sometimes market research or something, foundational information. Of course. Ah, the rag is dead. A little bigger on my side for this. Rag is dead debate. And it's a valid debate. 2 million plus token context windows, stuff everything in. High cost, dollar per query. High latency, prone to losing them. Those are all true. There are some models out there now that have a 10 million context window. So you might not need to throw everything in a rag. You throw a document in there, 2 documents, and you won't lose context. But the question is, can you throw multiple books in there? I have a project I'm working on this week and 2 days ago, and I had 16 books on a topic, and I was basically kind of building an enhanced rag around it. And in theory, I probably could throw it in a 10 million token LLM and be able to get all those in there, but then I might not be able to get all of what I want. They're not re-ranked properly, and they may not be organized as the best it could. I like this slide. There is a good example of a good slide from Gemini. Also, how do you evaluate RAG systems? Again, that should be defined before you start designing the process. Often in business, people want things done, but they don't figure out what is success? What is a successful RAG? Can it answer these questions? Can it answer that question? What can't it do? What can it do? Okay, and I'll just leave it as that. Prompting as a skill, we talked about that. We talked about retrieval generation. Retrieval is greater than generation. That's where all the fails are, is in the retrieval spot. Okay, so now let's see if we miss anything in this PowerPoint. This is week 10, 2026. I'll see if I remember. I'll post that chain of thought reasoning paper I'm working on. That's interesting. And this is a really let's covered it. So when we do prompting, we need API control prompting. We need to say, hey, I want JSON, I want YAML, I want plain text. We need to specify how we want the output. Why do we do that? Because again, we're dealing with thousands of prompts. Okay, wherever that thing is I was showing you a while ago. No. Right here. Okay, so what is the format saved using single JSON file? Now, why did we save them as JSON instead of just text? Yep, structured standard analysis. So now if I need to go back and analyze all these, and there's millions of tokens in here. I mean, millions and millions of tokens. It's much easier to analyze it when it says reasoning, blah, okay? Metadata for filtering, okay? How many tokens do I have? Or how many tokens are saved? I don't know if I can answer that, but I can't. So again, when I created this paper in this experiment, in the prompting, I wanted it to be very succinct, and I needed repeatability. Or to get repeatability, I did JSON. So I don't know. This is one of my personal experiments, and look at that. Probably approaching a billion tokens. I mean, 250 plus 250. That's close to a billion tokens. Nearly half a billion tokens. That's actually more than that. I can't do math. Oh, total tokens right there. I guess I can't read. Okay. So if you had a 500,000 unstructured documents versus 500,000 structured documents, it makes a huge difference. So when we ask you, say, hey, I need my output as JSON. I need my output as Parquet. I need my output as this. Well, we can go to ChatGPT, and this is a big gripe of mine, and I can say, hey, make a bulleted list or make a markdown file or make a Word document. I had Claude make a Word document yesterday for me. If you're in a voice chat, I don't even know where it's at. One of these things. Oops, where's my phone? How are you doing today, chat?
I'm operating at full precision, Richard. I hope you're having a productive day. Is there something specific on your agenda that I can assist?
Yeah, I want to make a Word document so I can grade my students. Can you make a Word document that says homework overall, midterm, and final, and then average, and just make a Word document for me?
I can't directly create a Word file for you, but I can definitely help you structure it. You'll just create a
So voice can't do that, but if I go to regular chat GPT, I can. Can you create me a Word document that has homework average, midterm, final, and overall grade average, and make a Word document so I can download it? I'll give that a second. So your output matters. I think that's something that a lot of people don't understand when they do that. So we go back to uh, yep. So here it goes. So download your Word document. I know it's kind of hard to see. Sorry, it's on my phone. Grade summary.doc, and I can upload. I can download. Oh, look right there. I made it. So in voice mode, I can't create a Word document. In regular mode, I can. But when we start doing APIs, it just becomes a bigger and bigger fundamental issue. When you're dealing with 500,000,000 tokens, you don't want 500,000,000 Word documents. You want something that's structured, that's the same all throughout. So, let me look at this here real quick. I should make it bigger for that. Okay. So basically, reasoning, as I explained, was just the machine improving its prompt. Okay. ChatGPT 3.5, 4, and 4.5 are not reasoning models, but they can reason by saying, "Hey, show me your thinking," for example. Yeah, so that's one of that. Is sometimes non-reasoning models are fast, and reasoning models are not particularly fast. They have to reason. Now, why do you care? I just showed you that. Hey, I'm sending 500,000,000 tokens. How long does that take? If you have simple, hey, I want to know the capital of every state in the United States. You don't need reasoning models. You don't need reasoning tokens. It's wasteful. Okay, so well, so if you don't need those, why use them? They just slow everything down. So always keep that kind of in mind. We'll test. That's here's the different types of logic: deductive reasoning, inductive, abductive. There you go. This was the very last thing we kind of talked about: open source and open AI deep research. I guess I can show you what that is real quick. Um, I think this will help you as a student more than it will help you per se in business. This allows you to have a foundational understanding of something. So hopefully you'll be able to use it and be able to get something out of it. When I first started using this, I used it from Hugging Face, and then OpenAI released it to the public, and then I think Claude now has it to the public. It was quite nice. Let's show you. Actually, we can just go. Okay, so I switched over to ChatGPT on my iPad. So what we can do is we can do deep research. What I need is a report on FT? I know I'm spelling that wrong. And other ways to optimize and train neural networks for my class next week. Maybe include dimension and alpha. Maybe include IQ, LoRa's. Oh, also you should include maybe visual LoRa's, how they're trained, or visual tokens. So I'm looking for one paragraph that explains the difference between fine tuning and low order rank adapters. And then the rest of the report should be on SOTA, LORAs. You know, some of these systems will ask you for additional questions or for follow-up. Some of them will just start code or start going out and research. So what this is it's going to take my question, it's going to try to enhance a prompt, and then it's going to try to go out and Google the first thing, recent surveys, comes back, analyzes that, collects industry post blog, comes back and analyzes that, and it builds on this deep research. Okay. Now this will probably take a guess, 2 minutes to 10 minutes. I'm not really sure how long. Um, so I'll let this run for a minute too while we keep talking about the lecture. And operator's kind of been replaced with ChatGPT browser. I don't even know what it's called. So in 2026, Atlas, I just looked at it downstairs or on my bar. So 2026, one of the big things that we're starting to see is desktop integration. Matter of fact, just today, Claude introduced or is introducing more desktop control. You know? Yeah, like I said, a lot of this has already been integrated in there. Mistral introduced a new model last week. Okay, so these are generally closed source models right here. Well, now I can't explain it. So closed source OpenAI, except for OSS, is closed source, meaning you can't download it and like look at it and change it. Okay, so let's go with this. Google, that's all closed source stuff. They have a couple open source that's on that list. Llama, so most of the Llama stuff is open source with limitations. Mistral is mostly open source, but they're starting to close up some of their bigger models too. Anthropic, which produces Claude, Opus, Sonnet. What's the other one? Sonnet and Heroku, whatever. Yeah, it's right there on the screen. Heroku. They're all closed source, so you can't download it and change it. DeepSeek is open source. QWQ is Quinn is open source. I'm not sure if Phi matches. I think Matches is closed source and Phi might be open source. 100% sure. So one thing I do want to talk about on here is never trust benchmarks. Never trust benchmarks. We just found out, I think this week, that Claude was cheating on their own benchmarks, and benchmarks are just a bad measurement of LLMs. They're a bad measurement of students. They're a bad measurement of something like GMAT or whatever it is that graduate students take to get into graduate school. Only predict the first semester success with any reasonable amount of accuracy. So, do you want your students that you admit to graduate, or do you want them to do good in the first semester? You want them to do good in the first semester, give them that whatever GMAT or all the tests we have to take. If you want them to graduate, there's better ways to analyze that. Same thing with LLMs. Benchmarks are a useless thing. Okay, visual tokens will cover down the road. Quantization will cover next week. It's a super important topic. There's Laura. We're covering this next week, and there we go. Oh, look at that. 60 minutes on the dot. Never happens. I know it's a lot of information. I know it's a little bit all over the place. I know Google's still looking for this report. Let me know if you have any questions. Really, the key takeaways from this semester or from this lecture are understand RAG. I think I put some extra links in there. Moving forward from this semester or from this week 10 going forward, I'm going to be relying a lot more on additional readings because this industry just changes too quickly for me to try to do a book or to try to have you learn something out of a book. The books are great supplemental sources. When you read the book and you say, "Hey, is this the best method?" Google it, interrogate it, keep moving forward. If you have any questions, let me know. Analyze Me is due in, oh, I don't know, 8, 9 days. Again, different domain, or sorry, same domain, different data. That's all I really care about. You guys have been killing it, knocking out of the ballpark. Let me know if you need some more examples. Let me know if you have any problems. Other than that, we had a great spring break and can't wait to see what you guys produce for Analyze Me. Thank you.